So for today's topic, we're going to talk about what cosecant of x is. We're going to talk about secant. We're going to talk about cotangent. We're going to talk about how those are all defined. We're going to talk about how to graph them, how to figure out what particular values are using our friendly unit circle here. And that's going to be the lesson for today. We're going to blend all those ideas together. So let's get started with the definitions for those three trigonometric functions. Right, so cosecant x would be notated like this. Now, a lot of people, they'll actually write it like this, and they'll leave off the parentheses. I think it's a very good habit to always denote the parentheses right here. It's a good habit because you can, put more values in here and start considering midlines, and so there's a reason why you would always want to include the parentheses there. So that's cosecant of x. Secant of x would be labeled like this. And cotangent of x would be denoted like this. Now, I wrote this in a particular order, but let's start off defining this one right here. And I'll help you out with this one. Cotangent of x is really equal to 1 over tangent of x. And all these values too, their domain is restricted, so division by 0, that never happens. So we restrict the domain, so this value right here can never equal 0. So cotangent of x is equal to 1 over tangent x. And we know what tangent x is equal to. We talked about tangent x. It's defined to be sine x over cosine x. So cotangent x, another way of defining it as well is, so this is sine x over cosine x, and then, so this is tangent x, 1 over tangent x, I can take it and I can flip it, because this is my reciprocal here. So cosine x is in the denominator, I can make it be in the numerator. So this would be cosine x up top, and in the denominator, that value would be sine x. So we can take our values and flip them. So that's the relationship, at least between tangent x and cotangent x. All right, yeah, you in the front. What's cotangent x defined as? 1 over tangent x. Very good, 1 over tangent x. All right, so 1 over tan x. Now, what do you think that cosecant x is defined? We have sine x, and we also have cosine x to consider. You know, what those values would be, like 1 over those values. What do you think that cosecant x would refer to? You talking over here. What do you think that is going to be? Cosecant x. 1 over cosine x? You know, I would think, so, and I always get these backwards in my head here. You know, you had a 50-50 shot. I'm going to explain how I kind of think of it too. So it's 1 over, so we thought it's 1 over cosine x. And what do you think that secant x would be? So let's just say that this was 1 over sine x. These both are wrong, by the way. I'm gonna point that out. These both are wrong. So notice how the S's match and the C's match here? It's always backwards. So it's always backwards. So instead of sine x being down here and cosine x being here, it's always flipped in my brain, at least, is that, so cosecant x is the C term is gonna go with the S term. All right, so that's gonna be what you're wanting to do there. And then the S term is gonna be with the C term. So secant x is going to be 1 over cosine of x. So that's how you do those. You kind of think of them as backwards here. So you do it like that. All right, so let's talk about how we start graphing these. All right. So what's this graph? Not here, but this graph up here. What is that graph called again? All right, yeah. Okay, what is that graph called? Tan? Yes, it's tangent x. This graph is, so this would be a graph of tangent x right here. Now, the reason we can figure out what these values are here and here is that, so we know it's from 0 to pi over 2. So from pi over 2, that's my vertical asymptote. If I add another pi over 2 over, because our step right here is pi over 2 units, so this is pi over 2. This must be another pi over 2, so it's pi. And then I have another pi over 2, so pi plus another pi over 2 is 3 pi over 2. That process just keeps on repeating. And we can graph it over here as well. Now, if we were wanting to graph what, so this is the graph of tangent x, and that graph is in red. So let's just write y is equal to tangent x. That's the graph that's in red. What I want to do is I want to graph what cotangent of x is. So I want to graph what y is equal to cotangent of x. Again, cotangent of x is 1 over tan x. So cotangent x, any value, any y coordinate, I'm just going to take it, I'm going to flip it here. So, and we talked about what pi over 4 is in terms of tangent x. We know that that value would be 1. So if I take 1 and I flip it, so here, I might move this down a little bit. Pi over 4 is really, so y coordinate is 1. So if I take 1 and I flip it, it's going to be the same number. So 1 over 1, so it's the same thing. So it is 1 right there. Now, the trick of this is to consider just this region right here. You're going to consider this region over here. All of our values right here are the important values right here. Ignore kind of the left side for now. So the first thing I notice is that you have 0 for your value of tangent x right here. So your height, your y coordinate is 0. So I'm going to take that value, I'm going to go 1 over 0. So that value is not defined. So I don't know what this value is in terms of cotangent x. That value right there, I don't know what that value is. Let's look where else I don't know it. Oh, right there. I don't know it right there because 1 over 0 is not defined. So we're excluding those values from our domain. We have this kind of idea going so far. Now, if you notice that this value right here, so this value right here is a value like 0.0001 right here. It's 0.0001. So that's my y coordinate. So 1 over 0.00001, we know that's going to be a huge number. If you're considering cotangent x, that's going to be a ginormous number. So what happens is the graph goes straight up at that value right here. So it goes straight up. So it keeps going bigger and bigger and bigger. 1 over a smaller and smaller number keeps giving us a larger and larger value. Now, if you consider this region of our graph over here, it's becoming larger and larger for our tangent of x portion. So if I take a value, let's say over here, I'm considering that value. That value is like 1 over, so that value is like 90,000. It's a big number. That's what I'm trying to get at. So it's a large value. Let's say it's 90,000. What happens is that your cotangent function takes that value up here and it says it's no longer 90,000, it's 1 over 90,000. And that number, some mental math. What's 1 over 90,000? Yeah, you right here. I don't know. What 1 over 90,000 is? Think about it's a fraction. You're saying it over here. 0. It's about 0. So this is about 0 right here. So if we're looking at this value, so it's 90,000. I take 1 over 90,000. It's dropping to about 0 right there. So it gets closer. It hugs. So it looks like that over here. And you notice that there's this there's this vertical asymptote for tangent of x right here. So we don't have a value in the domain of tangent x right here. That means that for cotangent of x, that value is also excluded in the domain. So we don't know what this value is right here. So we don't know what that value is right there. Now, if we're looking at it over here, though, we have like negative 90,000. So 1 over negative 90,000 is going to be about 0. So it looks like this. But notice that, and then so it gets closer and closer to 0 here. So it must kind of go backwards. So it goes like that. So it looks kind of like tangent does, except backwards a little bit. So that's the idea here. But let's look at this value at pi over 2 right here. Does anyone know what kind of discontinuity that would be? Is it it's not a vertical discontinuity. It's just a removable discontinuity. We took that value and plucked it out. So there's our removable discontinuity right here. Removable discontinuity right there. In this process, again, it repeats itself, so it's like it keeps going, and it looks like, it just keeps on repeating itself over and over again. The important idea, honestly, for graphing, understanding what cotangent is and tangent, is that tangent x looks like this, that I'm trying to get at least. Between pi over 2 and negative pi over 2, you know that tangent x looks like this. And it keeps repeating over and over again. And then for cotangent x, it just looks like this, but it's backwards written. So it's not like that. It's going the other way. Cotangent is looking like the other way. So that's the important idea that I'm trying to get at least. All right, cotangent x is 1 over tan x. Let's talk about what 1 over sine x. What's that called? 1 over sine x. The s term is paired with the c term, so that is going to be, we're going to talk about cosecant of x. Let's talk about how to graph what cosecant is. So let's talk about how to graph that function. So let's say we're wanting to graph, and I'm trying to switch some notation around. Let's call this theta. And then, actually, that was a bad look at theta. Looks more like this. All right, so there's theta. Let's say we're trying to graph what f of theta of cosecant of theta is here. Now, before I do that, the relationship is between cosecant x, cosecant of theta, and sine. So we're going to, first off, we're going to graph let's graph this first. F of theta is equal to sine of theta. Let's see what that looks like. We know that there's a relationship between these values here, because this is really 1 over sine of theta. So sine starts at 0, so it's right here. So it's 0 at 0. And then very important part of sine is that its amplitude is said to be 1. So this is a very important, make sure you do this whenever you're graphing sine and cosine. Its amplitude is 1, its distance here is 1, so make sure that's 1. And then it goes down here, so it's negative 1. So its amplitude is 1, it's this length from right here to here. So sine of theta, it looks, we talked about this in the last video, At pi over 2, the y coordinate's 1. At pi, it's 0. At 3 pi over 2, we're just going down 1 unit at a time. We're moving kind of like this. If we keep on doing this process, here, I'm going to move this -1 over a little bit. It's -1. It's right there, 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 and at -2 pi, it's right there. And then don't make these all lines here. They're not lines. They are the wave, so it has some curvature going on. All right, that's what sine x looks like, and we repeat this process down here. At negative pi over 2, my y coordinate is -1. At negative pi, my y coordinate is 0. At negative 3 pi over 2, my y coordinate is 1. At negative 2 pi, it cycles back around again, starts over, and this process repeats. So that's what sine x, sine of theta looks like. Keep calling it that. All right, so that's what sine of theta looks like. Cosecant of theta is 1 over sine of theta. So these values were, if we're trying to graph, I'm going to graph cosecant of theta. I'm going to use the black marker right here. If I go reciprocal of 1, so it's just 1. So this value is 1 right here. So we know these values are at least 1 here and here. I might move this a little bit. I'm just doing supercritical of my drawing here. All right. So it looks like this. Okay. So at every value that's 1, you know at least that cosecant of theta is going to be 1 right here. So we have this so far. And same with -1. We know that these values are going to be -1 because if you're going to take -1 and you're going to go 1 over -1, that value is also going to be -1. So we know these values actually are also plotted on our function for cosecant of theta. We don't know what 1 over 0 is because we see that height right there is 0. We don't know what 1 over 0 is. So this value, we don't know what these values are here. And these are actually going to be our vertical asymptotes. We have no idea what 1 over 0 is. So we're excluding those values from our domain of cosecant of theta. Like something like this. All right, so if we look right here, so we're looking here. If I take a value and I get closer and closer over here, so it's like 0.001, 0.00001, 0.0000001. So right here, you're seeing those values get smaller and smaller as you're going to take those values and they get smaller and smaller down here. Is that you're doing 1 over that value, so it becomes a huge number up here. So it actually, it goes way up top. So it goes way up top. And it has a vertical asymptote right here. And the same reason over here. So you see this symmetry right here. So it goes straight up over here. And then the difference between this value here, so if you're looking over here, it's more of a U shape going on. If you look at this value over here, this is negative. This is the negative value for my y coordinate. So if I'm going to take negative 0.0001, I'm going to go 1 over that. It's going to be a super large but negative number right here. So it's going to be a super large negative number. That value is going to correspond to being down here. So it's going to go straight down. It's going to go straight down. And then right here, you know that it also goes like this. And you can kind of just see the pattern that's emerging from this idea that it repeats itself. And over here, it looked like this. You know, and it would keep on repeating. So the black region right here, so these values here, you see that this would be the graph for cosecant of theta. Okay, so I hope this video helped with that concept.